In this part, after we have done an extraction of morphometric characteristics and parameters for the subbasins and for all study area basin, we finish and seal our work by making the factor analysis, where factor analysis is a statistical method used in studying phenomena with the aim of returning them to the factor affecting them. It is a mathematical process aimed at explaining positive correlation coefficients which have statistical significance between various variables. The factors resulting from the factor analysis process are variables like other variables, but with the slight difference that most of the variables can be measured directly, while the factors are hypothetical or latent variables derived from a set of variables that have been measured directly, meaning that factors arise from within a set of relationships between variables. The factor analysis method is one of the important methods that show the strength of each variable's association with the other and its distancing from other variables, and it works to derive the variables into groups and axes that share and interact with each other through analysis. So the most important feature of this method are the trend towards accurate, significant brevity. Factor analysis begins by calculating the correlation between a number of variables such as the variable x1, x2, x3, and x4, and we obtain a matrix of correlation between these variables in a sample. Then we then analyze this correlational matrix in a factor analysis to reach the fewest possible number of factors that enable us to express the largest amount of variation between these variables. Objectives of factor analysis: 1. It summarizes the variables in a smaller number of the main factors that can explain the phenomenon. 2. Highlight the set of underlying elements that are difficult to detect and that can play a role in explaining the relationship between a large number of variables. 3. Obtaining a new set of variables factors with a smaller number to partially or completely replace the original set of variables. 4. Identify the variables that have important statistical significance and that require further analysis, such as regression. 5. It is a useful technique for reducing complex relationship between a set of variables in a relatively simple linear form and reveals unexpected relationships. 6. It solves the problem of explanatory variables such as the problem of high correlation between independent variables, which leads to instability of the value of their standard regression coefficient in regression analysis. Now we are performing factor analysis, and in order to perform factor analysis we will need the statistical program which is located in the desktop entitled IBM SPSS, where we open this program. IBM SPSS Statistics. This page appears, and in it we have data view and variable view, where we go to variable view and to conduct factor analysis for the study area basin. We enter the characteristics into the variables view page as follows, where we go to Excel file that contains morphometric characteristics, and we choose basin parameter P. Then we go to the variable view and we type parameter or P in the name field, the type with decimal label values missing, columns, align, measure, and rule appear. In this field we keep the options as it is. Then we input the second characteristic, which is basin area or A, where we go to the variable view and we type A in the second line of the name field. Thus we enter the rest of the characteristics on the page of the variable view in the IBM SPSS program, as we see. After entering all the characteristics and parameters, we add another characteristic which is difference in elevation, where we go to the Excel file and in the first line of the next column we type difference in elevation DELEV, and in the second line we type the equation for difference in elevation, which equal the maximum elevation minus the minimum elevation, as we see. The DELVE value, which is the difference in elevation in meters for the sub-basins and for all study area basin, appears as we see. Then we insert this 30-second characteristic, which is difference in elevation into the variable view in the IBM SPSS program. And after entering all the characteristics and parameters in the variable view, we go to the data view. All characteristics and parameters that we have entered appear as shown here in the column or field heading. Then we enter the values of these characteristics, where we go to Excel file that contains the morphologic characteristics and we activate the values of perimeter and area. Then we make a copy for them. Then we make a paste for them in the perimeter and area field in data view in the IBM SPSS program. Then we add the raised values of the characteristics in data view in the IBM SPSS program, as we see. And with that, we have entered all the characteristics and parameters that extracted from ArcHydroTools in the variable view and data view in the IBM SPSS program. Then we save the characteristics and parameters that we entered into the IBM SPSS program by clicking on Save icon. Then we specify the save location in the desktop and we type the file name, which is factor analysis. Then we press save. The SPSS file is saved on the desktop with the title Factor Analysis. In this file, with the title Factor Analysis, in this part, we contend with entering all characteristics and parameters that extracted from ArcHydroTools and the IBM SPSS program. In the next part, we will continue with the factor analysis procedure.